Hello everyone, my name is Saloni and today we'll discuss a question that will be helpful to you for all physics competitive exams. And so our question says that there is a ceiling fan with 80 centimeter diameter blades. So diameter is 80, so radius is 40. It's turning at 60 RPM. That means omega is equal to 60 into 2 pi by 60 is equal to 2 pi radians per second. So first of all, what we have to do, we have to convert everything into SI units. Suppose the fan cause to a stop 25 seconds after being turned off. Okay, so we turn it off, and of course, it takes some times to completely so that our fan completely stops. So that time is 25 seconds. Why it takes time? Because initially it was in some angular velocity and it keeps on rotating, and because now there is no electricity, so definitely because of the friction it will eventually stop. Okay, so t is 25 seconds. What is the speed of the tip of the blade 10 seconds after the fan is turned off? Of course there will be some deceleration, right? So our omega final, so this we write omega naught, and omega is 0. So alpha is equal to angular acceleration is equal to this is 0 minus 2 pi divided by 25. This is our angular acceleration, and when we'll calculate this will come out as 0.251 radians per second square. Okay, so this is our alpha. Now we need to find the speed of the tip. Okay, so this is our alpha. We know that we will calculate this. Uh, this is our alpha. We can what we can do now. We can calculate angular. First of all, let's calculate angular velocity after 10 seconds. Okay, so we know that this is the deceleration. If we'll calculate the angular velocity after 10 seconds, then we'll apply v is equal to omega into r, and we can simply find our speed of the tip. Okay, so let's calculate our angular velocity in 10 seconds. Okay, so this is omega naught plus alpha into t. Omega naught we know is 2 pi. Okay, so this is 2 pi, and this is plus minus 0.251. Here it says minus, that means definitely it's dx, like deceleration. We know because our fan is being stopped. Now t is we know 25 seconds. So okay, now t basically here it's not 25, it's 10, because we need to calculate after 10 seconds. Okay, in 25 seconds completely stops, so angular velocity becomes 0. If you put 25 here, then angular velocity will come out to be 0. So after 10 seconds we calculate the angular velocity. This is 2 pi minus 2.51, and when we'll basically calculate this, we'll get this as 3.77 radians per second. So this is our omega, and now we can calculate the speed is equal to v is equal to omega into r, that is equal to 3.77, and radius is 40 centimeters. Okay, so this is 0.4 meters, and v will come out as 1 point. When we calculate this thing, this will come out as 1.51 meters per second. 1.51 meters per second. So this is our answer. This is our B. Okay, so this is our first part. Second part says this is not B, this is how. Through how many revolutions does the fan turn while stopping? So we need to calculate the total theta. Okay, and we'll just divide it by 2 pi to calculate the number of revolution. Okay, so theta is equal to, we know, omega naught t plus half alpha t square. And here we need to calculate number of revolution before it stops. Okay, so here our time is definitely 25, because it takes 25 seconds for the fan to completely stop. Okay, so this will put 2 pi into 25 minus half, because alpha is negative, 0.251 into 25 square. Okay, and when we will solve this complete equation, then we'll have 78.6 radians. Okay, this is our theta. And now we need to calculate number of revolutions is equal to 78.6 divided by 2 pi. And when you'll solve this, this will be 12.5 revolutions. So our fan revolves 12.5 complete revolutions before it comes to rest. So 12 complete revolutions and zero point 0.5 means half revolution. Okay. So these are the number of revolutions. Okay. So thank you for watching this video. If you like our content, please subscribe to our channel to learn more about physics.